So I think we can go straight to Müge's talk. I'm sorry, I cannot really read your full name, so you'll have to say it yourself.
Müge is my name, and my surnames are Kuyumcuoğlu, Tütüncüoğlu, so they are a bit tricky. Okay, let me start screen sharing. First of all, I also want to thank you for accepting me to present in this conference. And I also must celebrate, first of all, Mark's birthday as well as Ruth's. I am having a great time, and it is true for me as well that when I read Mark, some intuitions that I had were, they found their counterpart in his work. And this is the presentation that will show it, hopefully. Okay, so let me start sharing my screen. Yeah, I have slides. What happens when okay, I still see you. Great. Hold on a minute. Sorry. Okay. Yeah. Okay. My presentation is about framing and interactivism or interaction. Okay. So when it comes to the topic of framing, actually there are two perspectives we can take on it, two approaches that we can take to the subject. One of them is a kind of a critical account. So, and this is well discussed. And in Marx's work, this finds its place as a critique of encodingism, because or correspondence theories of representation by means of frame problems. And they show basically what mental representations cannot be, such as the argument. And it shows that what could not have been done without the capacity of framing itself. And then there is a positive account. We can formulate the question thus: how should we think about our capacity for framing and reframing in novel contexts? And what are the aspects of emergent based on this capacity, and implicit and explicit representation? And what does it mean to frame successfully? What are the implications? And I noticed that there is a lot of overlap with the previous presentation, so it's good. This one is on the theoretical side. I hope I got it right. Okay, and my outline of overall subjects. First of all, I will start with problem solving. I will try to demonstrate, and even interactively, how this topic comes up in well-defined, ill-defined, or and insight problems. And then secondly, we will talk about some preliminary definitions, what it means to frame, interpret, and heuristics. And then we will discuss the scope of heuristics. So can there be general heuristics at all? Context-independent heuristics. We will discuss this question by means of semantic classification or properties, the famous GRU examples actually. And then we come to the interactivist representation, notions of interactivist representation, the distinction between content, and also truth value. And then we will come to the capacity of framing. What is the difference between encodings and indicators, or in other words, explicit and implicit definition in terms of their interpretation by the agent? Okay. And I haven't looked up the time, but I would appreciate if somebody. Okay,
you started on 1822.
1822.
So 3 minutes have passed.
Okay, now I see. Okay, great. Okay, so there's a class of problems researchers call insight problems. They require the problem solver to perceptually or cognitively restructure the way they perceive the problem in order to succeed in solving the puzzles. A very famous typical example is the 9 dots problem. And I don't know, I urge you to, I don't know if you know the solution to this puzzle, but I urge you to try to solve it on your screen. So how do you connect these 9 dots with 4 lines without picking up your pencil? So the lines have to be connected to each other. Simultaneously, let me try to do it here. I hope I can. Okay, so. So I mean, the obvious thing we would try would be something like this. And you see, I mean, I couldn't solve it. But then this is a very famous problem. You have to do something like this. Okay. Okay, I have to. Okay. So, I mean, this is the problem that named, I guess, thinking out of the box kind of idiom. Anyway, and there is another example. Marcia and Marjorie were born on the same day of the same month of the same year to the same mother and the same father, yet they are not twins. How is that possible? I don't know if anybody knows this or can guess. Okay, shall I give the answer or shall I leave it to the end of the presentation? Let me do that. Okay. Okay, so according to Verweyke and Ferrari, connect the capability of construing restructuring patterns that are relevant to a problem solution with insight. And they differentiate between rationality of computation, which is of deductively following inference, and rationality of construal as framing and insight, as two cognitive styles that have different norms. And insight problems are contrasted to non-insight problems like board games, which are designed to be solvable via systematic consideration of knowledge and logical deduction or exhaustive search. Okay, then let's talk about well-defined problems. What are these are problems that are designed, they can be solved via exhaustive root search strategies. And a well-defined problem is defined in this way. The initial state, the goal states, the rules, and the constraints of operation in between these states are known. Yet, depending on the context of operation defined or the size of the problem space, vast numbers of possible operations may easily lead to combinatorial explosion of possibilities. Okay, and the alternative is using some sort of heuristics in reformulating the problem or framing. So here, framing concerns reformulating the problem so that the possibilities of solutions are limited in such a way that the problem becomes combinatorially possible to solve. So you basically learn some patterns. These patterns are heuristics, smart rules, and you follow them to limit the problem space to computationally manageable dimensions. And recall in the insight problems, there is a similar thing. Framing is required also to limit this combinatorial explosion. And there is also ill-defined problems. The importance of framing becomes even more obvious when we consider ill-defined problems, which correspond to most of life's problems. Typical examples are finding a perfect mate, writing a novel. It is defined thus: if the agent does not know either one or all of what constitutes the initial state or the goal state, the allowable operations they can make, the constraints that bind them, or the problem does not have a unique solution, how do they go about solving the problem? So here the case is not limiting the problem space through reinterpretation of the available operations in terms of a known goal, one first needs to formulate what the problem is and the goal is. And any act to the extent that it requires creativity seems to call for the capacity of framing or restructuring before inference can take place. So framing is required to avoid computational interactabilities, to avoid combinatorial explosion of possible operations via heuristics, to reformulate the way we perceive a problem via reframing, or to reinterpret a situation as a problem that can be solved via framing. As a result, framing is a prior or at least a precondition for exhaustive systematic inference or computing. Okay, so these were some examples. Let's go to some preliminary definitions. They will be working definitions, and hopefully at the end of the presentation, we will get a better idea what framing is. So frame problems are computational interactabilities resulting from combinatorial explosion of possibilities. And framing is contextualization in specifying context of operation. You can call it carving out the problem space or realizing relevance in a situation. Interpreting. And reframing is reinterpreting perceptual or cognitive restructuring of the way we see the situation or the problem space. Okay, the question is, do we have to frame every situation every time? We don't, because we have heuristics. Heuristics are familiar ways of interpreting things, and a heuristic is a rule of framing. And they are shortcuts that optimize cognitive resources, and they also work as biases, and they can be exploited. There is the framing effect, which is a cognitive bias that impacts decision-making when said in different ways. In other words, we are influenced by how the same fact or question is presented. Okay. In social psychology, participants are presented two or more options, but the outcome is the same, where they predominantly prefer one option over the other. Framing or priming, this is in social psychology literature. It is kind of like a functional blindness. It can be useful or it can make you blind. Okay, what these biases show us is actually, we can talk about biases towards situational aspects as well as cognitive problems. So framing is common to both procedural as well as propositional knowledge. So we can talk about visual biases, auditory biases, body language, value frames. Insight problems are cognitive examples. We saw them before. So I think this is important. Framing is common to know how as well as know that. And knowing that knowledge of facts, patterns invariant across wider context, albeit in different ways. I hope we will see later. Okay, scope of heuristics. Okay, let's come to the classical frame problem for a situation that can be characterized as a problem. So it has an initial state, a goal state, possible operations that allow one to go from the former to the latter, and constraints on the operations. We face three issues that disallow exhaustive strategies and necessitates framing. First, there is the combinatorial explosion of alternative paths. Second, there is the ill-defined nature of most problems and solutions. And third, ruling out to consider irrelevant data in the environment, such as irrelevant consequences of possible operations, without explicitly considering them. Think about a robot trying to make coffee in all the kitchens of the world. All three issues pose problems for computation since computation is explicit. And how to avoid this problem? Can we have a general all-purpose heuristic? One or few. We shouldn't have too much, otherwise we will face again a selection problem. That constrains formally without having to make explicit that which is left out. We are talking about an explicit heuristic that we can code program into the computer. It's like, sorry, it's like a blank check. Okay. Heuristics are background or general rules. Indeed, they can be learned. They can be construed and flexibly used by human agents depending on the context. Artificial systems also use heuristics for their fields of operation, which are tailored by their designers. Current working AI provides examples of varieties of systems which are delimited in their context, subject to control stimulus, encapsulated or supervised, and therefore specialized. But our question is this: for a general purpose system, can we define all background knowledge as a rule or few rules? This is the question. Okay, phenomenology would say no. Why? It would be endless. But why? So, I mean, okay, we can adopt the method of phenomenology and attempt to willfully ignore heuristics, trying to define background or common sense knowledge, but we will be always in the position of a perpetual beginner. Okay, let's see why. For a general purpose system, hypothetically, any fact may become relevant at some point of its operation. And what would a default heuristic look like for such a system? A background of the environment, for instance, saying that general properties of a situation do not change as a result of action unless otherwise stated. So imagine we formalize our general heuristic in this way. It is, you will see, it's kind of like a blank check, okay? But how do we cash this blank check out? General properties of a situation do not change as a result of action unless otherwise stated. Will it solve our frame problem for the general purpose system? Okay, what are those general properties of the situation that are assumed not to change? Shall we make a list of them? Can we make a list of them out of this formalization? Or is there a way to carve out properties without mentioning them? Okay, how about made up properties like GRU, the famous Nelson Goodman predicate, mock predicate GRU. GRU applies to any object observed before t and is green, and observed after t and is blue. For timing purposes, so I have 2 slides on this, but I will be quick. If you are not familiar with the example, it will be too quick, but the argument is in the text. Okay. Goodman's new riddle of induction, GRU, applies to any object observed before t and is green, and observed after t and is blue. Say we have observed 1,000 emeralds up to now, up to time t, and they were all green. Both predicates apply to, I get the, okay, my connection is unstable, so please let me know if you can't hear me and I will repeat. Both predicates apply to our observations. Emeralds 1 to 1,000 are green, and emeralds 1 to 1,000 are GRU, and emeralds 1 to 1,000 are green and GRU. And then we have the inductive hypothesis: all emeralds are green, all emeralds are GRU. Which we get conflicting predictions for times after t. Emeralds observed after t will be green, emeralds observed after t will be blue. Both predicates are confirmed by the same evidence base, but they give rise to different hypotheses and therefore conflicting predictions. Both predicates are well-defined regularities. Okay. So the question here is, let's remember the blank check. Why can't we accept properties like GRU? Why these general properties of a situation that we assume unchanging should be predicates like green? This is the question. Okay. Both predicates are well-defined. They are supported by the same evidence base. They allow hypothesis forming predictions. And the reason we accept green and not GRU as a property is not metaphysical. It's not the question is not whether there are uniformities in nature at all. It is not epistemological. It is not whether this particular uniformity is justified or grounded. The difference is semantic. The same phenomena can be described as a different regularity. And what counts as an instance of a regularity for us in a particular situation is not dependent on evidence base alone. It is about how we might frame the same experience as different regularities. So it's about pragmatic entrenchment. The reason we choose, we don't accept GRU, but we would expect something like green, is due to our pragmatic presuppositions. So there is no place for general heuristics. There is no a priori reason. A predicate like rule could not have become relevant in another context, but it is not relevant to ours. What rules to take as properties is not semantically given, they are pragmatically assumed. And relevance has to be present in order to have meaningful properties. The semantics is not given before relevance. It is even difficult to understand what a GRU is in some sense. And background familiarity commits us to a specific kind of ontology. Otherwise, we could include GRUs. Free Jones is Fodor's version of a GRU. We can discuss it if you like in the question part. The solution of a general heuristic would be circular. If we can assume a background rule, we can formulate it. If that rule is given, the context is already given. Then it is a particular or specialized context. The selection, construction, and development of heuristics are dynamic and they are subject to relevance. So they have to be constructed. Okay. So the examples so far show that framing is a fundamental aspect of cognition that cannot be accounted for on behalf of other cognitive capacities, such as categorization, induction, perception. The reason is that these other cognitive capacities themselves presuppose framing, and claiming otherwise results in circularity. And Goodman's GRU was a critique of syntactic and semantic models in favor of pragmatic entrenchment. And we will see that interactivism specifies a pragmatic solution by means of the contrast between contact and content. So let's try to see interactivist interpretation, how it applies to this problem. Interactivist notion of representation. Okay. So the perceptive flow of interaction is implicit. So first of all, some preliminary remarks, and then we will go deeper. A perceptive flow of interaction is implicit. It is intrinsically relational. It is already constituted out of indications of interactive relevancies. And any attempt to model this flow in terms of explicit, context-independent, atomized representations, which Mark Picard calls encodings, results in frame problems. These encodings are never direct. They are never foundational or directly given in nature. They have to be rendered and interpreted to be stripped of their relational characteristics in order to be formalized in the first place. And describing an apperceptive situation in all its contextual possibilities in terms of encodings requires the relations to be built back in, and we come up with interactability and frame problems. And what is interactive representation that can avoid these frame problems? This will be familiar to those who are familiar with the interactivist framework, but I have to say it. So the general course of an interaction will depend on the organization of the functional system in the organism that is engaged in the interaction, and it will depend upon properties of the environment being interacted with. And the interactive representation has three aspects. First of all, one is epistemic contact, correspondence or coupling with the environment, which internal outcome is attained after a particular interaction serves to differentiate types of environments. Those environments yielding internal outcome, internal to the agent, as are grouped together. Contact is provided by backward-looking differentiations, and this allows for selection for the agents because they can select based on this contact. Truth value is emergent. Let me come to it last. First, let me talk about content. Content of a representation is implicit. It is epistemic. It is the presupposed dynamics of the interaction, and this is the normative aspect of a representation. Presupposed dynamics are certain implicitly defined conditions, being the case in the environment. Presupposed dynamics are satisfied by the environment or not. The presupposed dynamics constitute indications of interactive possibilities as representations, and content is provided by forward-looking indications of potentiality. And truth value, if the associated internal outcome of the indications of interactive possibilities is not reached after an interaction, the indication. So representation is emergence in indication and selection. Notice the difference between truth value and truth conditions in traditional encodingist accounts where they are trying to formulate unbounded number of conditions which are captured by both contact and content. They are trying to anticipate these truth conditions, and it is actually unbounded, and we end up with frame problems. But then truth value here is totally something different. It is emergent. And let's consider our example, GRU. I don't know if we can say GRU is kind of like, this is my interpretation, GRU is kind of like a stipulated based on truth conditions alone, but it doesn't have truth value because it doesn't have relevance for us. This is my take on, yeah. So if truth value is the associated internal outcome of an indication of interactive possibilities, and if it is not reached, it is false or falsified. And notice that truth value is specified while truth conditions, contact and content are unbounded in an interaction. And if you, so it's the other way around than classical encodingist models. And if you specify a predicate with truth conditions without truth value, it lacks relevance. And this is what we get with GRU. I don't know if it is a good interpretation, we can discuss, but this is how I take it. Okay, so by means of, so let's come to the critical account.
Okay, 20 minutes.
20, thank you. Okay, good. So our capacity to control interaction or not, possibility of control of interaction by the organism is already sufficient to capture foundational properties of representation by means of implicit indicators, we see, and explicating an interaction in terms of explicit encodings end up with frame problems. So this cannot be the basic nature of human representations. So this is the critical account. I haven't said much about the positive account yet. We will come to that. Okay, also I have to mention epistemology of objects. This is also definitional. Closed and invariant patterns of possible actions make up physical object representations. They are constructed. They are closed because you can reach each interaction from the other, and they are invariant under large class of interactions. Under large class of familiar interactions, they are the same, but of course they can change. Object representations are emergent out of interactive representations. The representation of the toy block is already construed out of webs of possible interactions. So relevance is already built into it. This is important. Representation is of future possibilities for further interactions. And the representation itself is constituted out of these relevances. So there is no framing, and the framing is already present there. Okay, let's come to implicit definition, because we talk about the implicit definition. Possibilities of interaction co-vary with environmental properties, but those properties are implicitly and not explicitly represented. So I quote Mark Picard, an indication for the frog, for example, that there's a tongue flicking and eating opportunity is unbounded with respect to the number of actual flies or fly conditions that would support it. And interactive implicit definitions are generalized from model theoretic interpretation of axioms that implicitly define. They fix a class of models that satisfy them. The class of models that satisfy are unbounded. There is no a priori limit on them. And appropriate satisfiers are set to interpret a sentence such that they make it true. So axioms are not taken as, I mean, in the context of geometry, in maths, the axioms are not taken as laws, they are taken as definitions. But these definitions are relational, and we will come to how it applies in the interactive context. How? So what is the role of implicit and explicit definitions in framing or reframing of situations? How do we use this in construction of frames? Let's go on to variation and selection processes. Framing in interaction. Okay. Framing, then, is an act of interpretation where relations of relevance are realized. Framing applies to any situation which is interpreted, procedural or propositional, but importantly in different ways. And this hinges on the distinction between how indicators are interpreted versus how encodings are interpreted in the interactivist framework. Okay, so we have a use for encodings actually. So we use symbols, we have many explicit representations. I will give some interesting examples later. And they must have a role. We have them, they are everywhere. First of all, they are not direct encodings. They are derivative. They are derivative from indicators, which are interactive outcome indicators. So encodings are derivative on indicators. They are explicit and they are explicitly constructed. They are not given or foundational. They are constructed on top of, let me say, indicators. And representation via standing relationships is the peculiar essence of encodings, legitimate encodings that we can talk about within the interactive theory. And encodings are never interpreted directly like indicators are, but there's a tricky bit. The difference between them is functional in the way we use them, in the way they are interpreted. And with sufficient practice, learning or convention, an encoding may become an indication for an agent. It may become very, it may become a part of their perceptive flow with enough practice. And now we come to this part. So there is a fundamental difference how they are used, and this is, yeah, a functional difference. How encodings are used is that they are, or processed, they are interpreted via inference. They are processed to trace back to the indicators, and processing involves explication, filling in, tracing back the relevant standing relationships. And interpretation involves standing explication, analysis of explicit definitions. But indicators, implicit definitions are used, or they are directly picked up. They are interpreted in a different way. They are interpreted directly by feeding into organism internal procedures, directly into the perceptive flow, because there is a coupling relationship between the organism and the indicators that they use. And interpretation involves model theoretic implicit definitions. We don't know what characteristic of the environment they stand in for or correlate with, yet they satisfy or not. So they are implicit, and the other one is explicit. Okay, so let's say we have the properties in the P1, P2, P3. Okay, we don't know the common characteristic, let's say brownness or blackness or legginess or fast movingness, but we know they serve the same purpose and they are different from P4, P5, P6, whatever they are. They may be these, whatever describes these. So this may be prey, and this may be predator, whatever. Their relationship to each other is defined, and we can differentiate them as being different, but we don't know what they stand in for or represent in the environment, because we saw before that is unbounded. We saw it with content, that part is unbounded. It's implicit. Okay. So, okay. If the difference between implicit and explicit is a bit clear, the definition, another puzzle. Is this explicit? Please read the below sentence to yourself. So we know the meaning of the words. It's very straightforward, very toy example, but it is a bit surprising, no? So it should be interpreted like this. Police who police other police who police other police. Okay. So the previous example demonstrates the difference between explicit and implicit interpretation. it is not structural, but it is functional. There can be a functional shift between explicit encodings and implicit indicators by means of practice, if we are familiar with it. Practice is interactive. It may be mental, it may be cognitive, it may be imaginary, it may be projective, as well as physical. So another example, counterintuitive, perhaps, example of marking in dance. So it seems that there is a phenomena in dance. There's a practice called marking. When dancers mark, they execute a dance phrase in a simplified, schematic, or abstracted form. So imagine dancers, they are learning a new phrase, and as they are learning it, they do, this is kind of like a rehearsal practice. It is not executing the full out dance phrase, using all of their body, all of the movement, but this is not totally in their head either. They represent some aspect of the phrase, the dance phrase, with their body. For instance, they do something like this to practice, or they do moves with their hands. The thing is, they don't only mark for coordination purposes or communication purposes. They do this, they mark for their, they mark also for themselves as part of rehearsal or practice. So marking for self, it's the practice of creating a simplified version of a process, a personal model to work and think with. Based on our interviews with professional dancers in the classical, modern, and contemporary traditions, it is fair to assume that most dancers mark in the normal course of rehearsal and practice. When marking, dancers use their body in motion to represent some aspect of the full-out phrase they are thinking about. Their stated reason for marking is that it saves energy. It avoids strenuous movements such as jumps, and sometimes it facilitates review of specific aspects of a phrase, such as tempo, movement sequence, or intention, all without the mental and physical complexity involved in creating a phrase full out. It facilitates real-time reflection. So they create kind of like an explicit model of the dancing phrase, which is very interactive. Sometimes, even when you know something, it is good to mark it through, to rework it in your brain, to make another idea of what the movement is. This is quoting a dancer in the interview. So, I mean, this is, I think, an interesting example. It is demonstrative in showing that we go back and forth between explicit representation and implicit representation in working out the details and learning. And here they are trying to learn the execution, their execution, and they create models with kind of like indices. They create explicit representations with their body, and this is the way they work it out. So framing, it goes back and forth between explicit and implicit. So interactivist theory, the model talks about conflicting goals between computational efficiency and developmental efficiency. Computational efficiency requires specialization so that it is quick, it's familiar, and it is very specific. Remember the police example. Once it is familiar, it is very quick, but it is specific. And then there is developmental efficiency. It requires generality, that it applies to novel contexts. It applies to many different contexts. And there is a trade-off between these. And during the construction of new elements, while solving novel problems, working with copies as working models, as single whole elements to flexibly try out and interact with, satisfies both of these constraints. Because practice, frequency of use enables these copies to be integrated into specialized procedures. And then they are constructed as new specialized heuristics. So this is the interactivist take on heuristics construction. So I can go a bit more. I have a little more. Okay. Let's go.
6 minutes, yes.
Yeah, okay, perfect. So let's dwell a bit more. What is the purpose of operating on indicator-derived encodings. Remember, these encodings are not foundational or given. They are also derived from the indications. The purpose is to transform the general heuristic into specialized ones, it may be. So you have a general heuristic, but you want to apply it to a particular context, particular circumstance. And also, you want to retain the original result of a tryout, because the tryout may not work and it may be falsified, but you don't want to get rid of all of your knowledge of general dancing. Also, to separate and protect the information in the encoding from the ongoing operations of the interactive flow of perceptions, because computing sometimes takes time. It takes time and resources. It is resource intensive. It may be a difficult task. So all of these are reasons why we work with explicit models and encoding and decoding procedures. So we encode and then we decode. Encoding and decoding procedures enable copying into a stand-in, specialized or toy models and integrating them back into the derived indicators through practice. So derived encodings as stand-ins for indicators, like working copies, created to be used in novel situations to make inferential operations on them more efficient and much more powerful, actually. But they are always subordinate within an interactive knowing system, which is at base indicator-based. And this is key. They are not like standalone encodings like the encodingist framework. Okay, this is a quote from encodings then are used in novel situations in order to make use of the potentially immense power of potentially vast array of strategy, decision-making, and inference procedures. In so doing, they tend to step out of ongoing interactive and apperceptive processes via the encoding step, and then, if relevant, to step back in via the decoding step. With use, both the encodings and the general procedures tend to disappear from those computations in favor of directly interpreted indicators and specialized procedures whose computations participate directly in the interactive and apperceptive flow. Okay, this is it. Just a recap. So problem solving shows that framing is a precondition for computation. Framing and heuristics apply to procedural as well as propositional contexts. And there cannot be all-purpose heuristics because semantic classification is parasitic upon pragmatics. Interactivism materializes the pragmatic solution by means of the contrast between contact, content, also truth value, I must say, and the use of, there is a difference between, a functional difference between encodings and indicators in terms of their functional use that we make of them. This is it.
All right.
Perfect. Yeah, 3 minutes left even.
Yeah. Okay.
Okay, questions?
Shall I stop sharing? How do I do that? Ah. Okay. I don't know if you think my interpretation is correct of the GRU. I would be curious to hear your opinions on it too.
Okay, Johanna.
Yeah, wonderful. Thank you so much. Could you elaborate more on the idea that encodings are derived from indications?
Okay. Yeah, so that part was a bit too fast. Let me say like this. They are also indication-based. So they are also action-based. So remember, there are also models that we can interact with. This is the sense in which they are indicator-based. So remember the representation, let's go back to object representation. We said the object representation is made up of webs of possibilities of interactions. They make up this object, toy block, let's say, and it affords some sort of interacting with it. Similarly, we can construct these encodings as kind of like objects we can interact with, that have some rules of interacting with, that have some invariances of interacting with, and we can, yeah, the way we work with them is also by interacting with them, by using them in a way. So thinking is also interactive. I don't know if it makes it clear.
So Hannah, do you want to ask further, or?
Well, perhaps we can also put the question further. Maybe also my confusion is that I can understand that something like a symbol is generated, or some sort of a stand-in is generated. It works as a second order indication. It was just that the encoding seemed, that was, maybe I was confused about what you mean by encoding.
Okay. So let me, okay, so there is something, for instance, maybe I'm trying to share screen again. Let me go back. Okay. Yeah, sorry. Okay. So it's here actually. So the way, so encodings, let me start from here. And encodings, so there are two notions of encodings. So it is also difficult to explain in that. Well, there is the encodingist framework that we want to refrain from, and it defines, it is based on truth conditions. It is, it takes encodings to be grounding or fundamental, that kind of like they are given to us directly. So this is a rival theory, but here, but also in there is a truth, a kernel of truth in this idea, and which is this, in a minimal sense, let's say. So the peculiar essence of stand-in relationships, they are stand-in relationships. So X represents Y in terms of standing in for Y, okay? And they are stand-in relationships. The thing is, ultimately, stand-in relationships end up in a circular regress. They don't work. So they have to, at some point, these explicit encodings, which are explicit stand-in relationships, have to be derivative on implicit representation. Otherwise, it is, and this is exactly what you are asking, the derivation or the dependence on the indicator. This is not in the way they are generated. This was actually a comment in the previous presentation. The difference is not in the way they are generated. The difference is in the way they are used. They are consumed. So we have a perceptive flow, which is interactive. It is implicit. We are dealing with many things at the same time, and then this is a different way of interacting. And then there is the way we interact with explicit representations, which is different. It is inferential. It is, I'm not sure reflective is the right word, but the way we interact with these encodings, the models, is different. And this is the key difference between them. The difference between them, so this was the purpose of the example. Where was it? This was the purpose of this example. This example the difference between them is not structural. The difference between them is not in its essence. The difference is how we use encodings versus indicators. While using indicators, we are not explicitly aware of it. This is is it more clear?
I imagine Mark will have a lot to add here, so
Yeah.
maybe we move on to Mark.
Yeah.
Okay. Well, thank you. That was great.
Let me stop share.
Pardon? Oh,
Okay.
yeah.
I stopped share. Okay.
Some things I might word a little differently, but I thought it was terrific. I have a couple of comments and a couple of just sort of suggestions. With respect to this last issue, this discussion of turns on a very broad sense of stand-in. And if you try to cash out the dynamics of stand-in, it turns out there's more than one kind. So the sense in which the neutrino counts in the gold mine in North Dakota stand in for properties of fusion in the sun is an epistemic sense. One stands in for the other in the sense that it allows us to infer, so long as we know about all the relationships and so on, to infer the fusion processes or properties of the fusion processes from those neutrino counts. What Müge was mostly talking about were what I've talked about as internal stand-ins. And those stand-ins don't exist, at least at first knowing level. They don't exist as epistemic stand-ins. They exist as functional stand-ins. And the intuition here would be, in a computational framework, something like pointers. So if you have a stand-in that's developed that points to something that is directly in the interactive flow, you can then have processes that occur with respect to that stand-in, and then can be translated, if you want, back into that interactive flow at the end via interpretation, quote unquote, but it's not an epistemic interpretation, it's a functional interpretation back into the interactive flow. And the quote that Müge gave from the '83 book is talking about that. There's a later paper called Levels of Representationality that also talks about this. My argument there is that, yeah, these are useful. And they look sort of like encodings because, and you can maybe even use the term for it if you use the term broadly enough. But they're stand-ins of a somewhat different kind. They're functional stand-ins rather than epistemic stand-ins. And they're useful precisely because they allow you to have some sort of process flow that is not directly involved in the interactive flow with the world, but can become re-involved. And as Müge pointed out, if that happens often enough, they'll tend to get habituated, and these stand-in relationships will tend to get muted and even eliminated. And so they can become directly part of the interactive flow. So that's at least one. Let's see. I thought it might be worth giving another angle. This whole idea of implicit presupposition, dynamic versions of it, dynamic versions of implicit definition, is actually the result of more than one thread in my own thinking about this stuff, that they've all turned out to come together. Implicit definition is originally a formal logic notion. Presupposition, I actually got from language, the sense of a it's an inadequate sense of presupposition, but the sense in which the present king of France is bald presupposes something. So, I mean, a lot of different sources, but they all came together. So here's one way they came together. It's not the only way. In abstract machine theory, if you've got an abstract machine thought of as a bunch of states with a bunch of transitions, and if you're in a particular state and you receive a certain input that induces a certain transition to some other state or maybe back to the same state, So you can think of this, you can visualize this in terms of the states as points and the transitions as labeled arrows. So the states as points are maybe named S0, state 0, state 1, etc. The transitions are labeled by the input that evokes them or invokes them. I might note that this gives you a strictly discrete model. It doesn't give you duration timing. And there's all kinds of ways in which this is not fully adequate. But anyway, okay, so now consider one of these things. If you fix a start state and you fix some subset of states as final states, this will differentiate the class of input flows, the class of input letters that will, given the start state, leave you in one of the final states when you're done with the input string. This is what's called a Raven-Scott recognizer, or just a recognizer. So it recognizes a class of input strings. And notice it recognizes the class of input strings not via explicit definition of what they are, but rather by at least a first step in the direction of a dynamic implicit definition of what that class of input strings is. Okay, it's a first step, I say. This notion of abstract machine doesn't have any outputs as I've defined it so far. Let's now suppose that it can give outputs, and there's different ways of defining that, but one is every time it enters a particular state, it emits an output dependent on the particular state that it has just entered. Well, okay, that doesn't actually get us much new. But now, let's suppose that we have a model of the environment, and those outputs from our system go into the environment. And the environment could also be, for these purposes, an abstract machine. So the outputs from the system are inputs to the environment. And depending on the state that the environment is in, will evoke further transitions in the environment, which will evoke further inputs back into the system. So now we have a fully interactive system, although it's discrete, et cetera, other problems and limitations on it. But it's a fully interactive system. So now the recognizer will not only implicitly define the class of input strings that it recognizes, it can also potentially induce a recognizable string via its outputs. And via this potentiality of inducing a recognizable input string, it will implicitly define the class of states in the environment from which it can induce recognizable input strings. So we have kind of a double implicitness here. And that's clearly a kind of a dynamic generalization of implicit definition in formal logic, and implicit definition in the purely linguistic sense, implicit presupposition of the present King of France. Multiple intuitions that I kept coming across turn out to end up in the same place. They get modeled by the same kinds of dynamics. So that just gives a further sense of what is being meant here by this notion of implicit definition. And then finally, I would mention two things. Something that sort of overlaps with what you were talking about earlier, especially the framing and how framing is itself dynamic, and we have to figure out frames. Cliff Hooker and Christensen have talked about what they call self-directed adaptive learning. And what they're talking about is precisely the sort of dynamics that you're talking about. And one of their examples is the detective trying to investigate a murder. Well, investigating a murder is a very, very broad, ill-defined problem. And so in the process of trying to investigate the murder, one of the things that the detective is going to be trying to do is to try to figure out what kind of a murder it is. Because the evidence that would be relevant will depend or be quite different if it's taken to be a murder of passion than it is if it's taken to be a murder of finance or something like that. So there's this iteration back and forth, and very deliberate iteration back and forth in this particular example, between trying to solve the problem and trying to define the problem. And you have to do both. If you simply try to solve the problem in the broadest sense without ever coming up with a more refined definition of the problem, you'll never get there. You run into all the intractabilities you were talking about. One example of these kinds of intractabilities at a very, very simpler level is in certain species of birds, the chicks peck at the beak of the parents to induce the parents to regurgitate food for the chicks. Well, easy, quote, rich interpretation of that is the chicks are representing the beaks. Well, no, they're only differentiating the beaks. It's implicit, and the boundaries are not explicit, and the boundaries may not be known in the standard environment because the boundaries go beyond what occurs in the standard environment. Turns out the beaks in this species of the parents have little red spots under them. And the ethologists discovered that if they take a wooden pencil with a red eraser and stick it in front of the chicks go nuts and they start pecking like crazy. And the ethologists called these super releasers, and so on. I mean, we can go on. The point is that it's a differentiation process that is intrinsically unbounded. It is not a denotational, referential, directly referential process. So that's another good example. And then my last one is, I believe it was Nichols. This was years ago that I read it. Nichols talking about a certain episode in the biography of Einstein. And in fact, what Einstein won his Nobel for. Well, one of the things he won it for. He was trying to solve the problem of black body radiation. And lots of people had tried to solve the problem of black body radiation, and there were a bunch of mathematical constraints on what would be acceptable as a solution to the black body radiation problem. And like I say, people had attempted to come up with solutions to it. Einstein realized that collectively, this set of mathematical constraints was inconsistent. There was no possible solution to it. And he ended up altering one of the mathematical constraints for, very good reasons, and was able to come up with a solution. My point there is that that's a very formal, in a certain sense, famous, although not well known, example of the importance of framing and the essentialness of framing to being able to come up with any solution at all. So, okay, those were my comments.
Sorry to interrupt. So we are already a little bit behind the schedule. So let me propose this. Since my talk is next, I'll just go and grab some tea and stuff while you can still chat, or if someone wants to go and also get a coffee, you can do that while questions are being asked. And I'll just pass control function to Uz. Okay.
Okay, so Mark, if you are done, I think it's Ken's turn.
Yes.
Ken, you are muted.
Sorry, there we go. I should be audible. Sorry if you regret my being audible, but first off, thank you very much for the talk, and Mark for your comments too. And I just want to mention what gave me a bit of trouble tracking this about indicators and explicit or encodings is that the indicators seem sort of most naturally understandable in terms of perceptual motor negotiation of the environment. Now, there may well be important counterparts to that with something more explicit, as in Mark's example of someone trying to solve a murder case. But what I wanted to do was offer a different observation about Goodman, a contrasting article comes to mind in this connection about indicators, and perhaps also what you were saying about marking in the dance. Namely, there's this wonderful discussion Goodman has in his article, When is Art? About samples. Right? He talks about using samples as, you know, an actual chunk of the item that we're trying to learn to understand or to characterize or properly to identify. And it's a terrific discussion, and there's nothing gruesome about it, right? The examples are stable and they're identifiable. And they're not the kind of perceptual motor interactions that seem to be central to your indicators, but it may well be the kind of marking that enables us then much more accurately and intelligently to identify and discriminate, right, to differentiate that kind of stuff, right? His examples are fabrics. Take your pick. Anyway, I just thought I'd offer that as a self-diagnosis of where I had a bit of trouble in the middle of the talk and a possible wedge to use against Goodman and his absurd problem about emeralds. If he doesn't like his emeralds, he can give them to me.
Thank you. Thank you, Ken. I will.
You're welcome.
Okay, Georgie.
Hey, thank you, Müge, for the talk. I have two comments, questions. Let's say at some point in the presentation, I think at the very beginning, you said contrasting these two explicit and implicit web of interactions as representations of objects. You said, at least I thought I read that the relevance is built in those. What do you mean by that when you say relevance is built in those representations?
Thank you.
I believe I saw that on a slide.
Exactly. Thank you. Thank you for the question. It is meant in this way. So when we talk about indicators, we talk about the internal process of the agent and how so in order to be able to interact, the functional capacity of interaction already presupposes that that capacity is relevant to that interaction. So, for instance, okay, a silly example, but so I mean, I have a hand. I can hold this pen. This is my capacity. This capacity is. I mean, when you talk about a functional capacity to interact with, that is already relevant to the interaction that you're achieving, if I may say. And this goes on also for abstract things as well. When so let's not go to the encoding becoming indicator with time, with familiarity. But I mean, the success of the action or interaction itself has to involve the relevance already. I'm not sure.
Oh, yeah, I think to me, when I hear relevance, it has to assume some sort of a problem or situation or a way of viewing the object or the situation for which the object is relevant, or parts of the properties of the objects are relevant. So I don't see how can that be like built in already there.
Okay, so the first of all, relevance is a wide concept. So so you can talk about relevant interactions in the environment, for instance. The original frame problems were something like this. Also, the general heuristic was something like this. So I take an action. I make coffee. And after I make this coffee, I don't know, the color of the walls of my kitchen is not relevant to this a perceptive flow that I engage in, let's say. The relevance of indications is, first of all, guaranteed in my being able to interact on one side. So
but you see how that that stems from your goal that you want to make coffee and not to paint the walls. The relevance stems for your goal that you want to achieve. You want to make the coffee, and that's why the painting or the color of the walls is not relevant indeed. And okay, so maybe we are cross-talking, I don't know.
Sorry to interrupt. Mark raised his hand at a particular point.
Mark,
so if it's a clarificatory, Mark.
Yeah, let me make a quick attempt here. There was a literature for a while, I don't know if it still exists or not, addressing what people like Gazdar called relevance theory. And it was built around the frame problems. And the idea, as Müge said, and I think said quite accurately, is, look, if you reduce all this to a bunch of particulates in isolation, which you have to do if you're going to reduce it to encodings, and even more so if you assume that the encodings in some sense are pre-given. But anyway, if you reduce it to these isolated encodings, then you have to figure out what's relevant for what. Relevant in any sense with respect to a problem, or relevant with respect to what you could anticipate if it were relevant in a problem-solving sense, but you could anticipate it in principle even if it weren't relevant in a problem-solving sense. So what's going to change? So that was the way Müge introduced it. And it's intractable. It's very easily demonstrably intractable. The original formulation of the frame problems was in terms of a robot that was supposed to leave a room or had a bomb in it or whatever. Do the walls change if the robot pulls a wagon that has the bomb on it? And you can invent all kinds of situations in which things that were originally not relevant become relevant. And that's kind of known to us, but there seems to be no ability, no way, because it's intractable, to specify what all those relevancies are. And Müge's point is that at least relevance with respect to anticipation is what counts as representing in this model. So you don't have to build the relevances back in. You already have them. Now that doesn't guarantee that you've got all of them. So this doesn't give you an infallibility, but it means that since the relevancies have implicit content rather than explicit content, it means that you don't have to solve this intractable problem in order to resolve the issues of relevancy. There's always more to learn, but the more learning is not going to be moving into this intractable, unbounded implicit space. It's going to be moving into this realm of presuppositional implicitness.
Oh, okay. So Müge, just to recapitulate this, of course, yes, the whole approach of schema-based, like frame-based AI, you have the restaurant frame, you have all sorts of frames, but that's also, it's impossible, and you have infinitely many such frames that was supposed to solve the common sense problem. Like if I am in a restaurant, I will use the restaurant scheme. I think Shang called them schemes, like in AI. So you have this by default built-in relevant things in a restaurant, like tables, plates, who sits where. So this is pre-built in this. And obviously this is an explicit representation and doesn't solve much, and you cannot have. So here with the interactivist representation, what I'm now understanding Müge suggested is that at least here you have this possibility through the back and forth between explicit and implicit, explicit encoding. It's built on the top of the potential or indicators. You can go back and just fetch another possible type of interaction, which suddenly becomes relevant for that frame, and maybe solve the situation by giving you the specific, explicit, linguistic maybe framing of the situation.
I think part of the problem here is that the word frame has been used by lots of different authors.
Yes.
And in general, in sort of related ways, or at least they look related.
And scheme, I think interchangeably something. It was,
yeah, Minsky's frames, Shank's scripts, Goffman used the word frame in a kind of a related way. But they're not all identical. So it would take more careful work to figure out exactly what all the interrelationships are among those usages of the word frame.
Okay, thanks for that, Müge and Mark. But the second question, actually, I put it in the chat again.
Georgie,
I guess nobody's.
Georgie, I think we're short on time. Would you mind saving your second question so that
Sure.
Ask a question and then
Okay.
Thanks.
Hi, Müge. I'm not familiar with the framework, so excuse my use of the terminology. But I was wondering, I mean, when it comes to color interactions, if you can call it that, since 4-year-olds or starting from 4-year-old, infants, or even birds, as Mark Bickert gave examples to, can recognize colors in very, robust ways. Doesn't it show that Goodman's worries are a bit off the point, in the sense that color perception has some stability and naturalness, and it's not pragmatic entrenchment? I mean, infants wouldn't know about pragmatic entrenchment, etc., right? So it seems like there is a natural aspect to our interactions with surfaces, exteriors of surfaces, that enables us to recognize them through their colors. And Goodman's points would not help you much within this framework. But that's a question. I don't know.
Yeah, thank you. So surely children or animals are able to differentiate on the basis of colors. I mean, they are able to do this. So you are saying, I don't know if I interpret your question correctly, but you are saying colors are invariant and GRU is not a good example.
GRU is very artificial. I mean, you can teach children or animals to recognize colors like, GRU, right? So it's not part of our natural interaction with the world. That's my
you said you can or you can't?
You cannot.
You cannot. Yeah, exactly. So
I mean, given that our inductive procedures derive from practices that we come to learn, it's much more natural that, we would make up our kind terms or object classifications on the basis of natural colors like blue.
Okay.
So, I mean, I don't see the relevance of the GRU problem for the frame problem or the issue you were talking about.
Okay. Yeah. Okay. Yeah. So, okay. First of all, and the guru, the predicate guru is. I agree with everybody. It is silly, but I think it is made to be silly, and the way the take for granted and that which we can differentiate is still it is based on what is familiar to us. You can say, you can call it, it is based on our way of life. So it itself is not directly given in nature. In nature, there are many differentiations that we don't make use of. So we don't have a predicate for everything. We have our predicates that we make use of. The children and animals can differentiate colors, and the colors are invariant, and this is why they differentiate. So the colors are useful, so this is why they can differentiate. I take your question to mean something like this. Why can't I form a general background assumption using properties, and I can cache out the properties, but I have to cache out the properties as what is familiar to me anyway. So the way I cache out the properties is because I'm familiar with the environment, because I use, I differentiate color. I take color to be a property that would stay the same, let's say.
No, things may have different colors at different times. We don't claim that, you know, leaves on a tree always have the same color, right? But it seems like, given the naturalistic framework you seem to be employing, we don't need to worry so much about artificial predicates like grew. I mean, we have to pay attention to natural properties, even though color itself is a very questionable property.
Actually, exactly. So
can I make a warning? Sorry, Müge, can I make a warning? We are now half an hour late, so we are eating away from lunchtime. If everything goes okay with Robert's talk, so is it okay if we just move really fast to Jorge?
One sentence, I just want to answer.
Sure. Yeah, sorry, sure.
Yeah, the whole point of the GRU example was we don't pick predicates like GRU. I mean, the conclusion was that we don't prefer predicates like GRU. We prefer predicates like green. And why is the reason for that? And the reason for that is pragmatic. This was it.
I doubt that, but anyways, I doubt that it's pragmatic.
Okay.
Infants, you know, can recognize colors easily, or birds can recognize colors. But anyways, yeah.
Okay, Jorge?
Yeah, thank you. Could you comment a bit on the relationship of your reframing and metaphorizing or blending? To be concrete, in the 9-peg and 4 lines example, some subjects would metaphorize or hallucinate this as a bowling game. So you have you throw 4 times a ball to sort of kill your pegs, and in this way they get very naturally to this non-obvious solution. Do you see a meaningful relationship with this sort of hallucinatory metaphorizing?
Yeah.
Within a framework.
Yeah, so remember in the dance example, marking in dance, I will get back to it. Actually, I just mentioned it. The author was talking about 3 sorts of rehearsals. So you can rehearse in your head, totally imaginary, a dance move. You can rehearse it in your head. You can rehearse it in full, just execute A to Z. Or marking is something in between, half imaginary, half execution. And the purpose of all of them is to interact and to get familiar with what is possible, what is not possible, what I can do, what I cannot do, what is the constraints. And the example that you give, that you can solve, for instance, the 9-DOS problem by means of hallucination, strikes me as, or metaphor, strikes me as something like this. You in metaphor, you solve the problem in another context and you apply it to the same context, just like Mark's example of avoiding obstacles and also drawing what to avoid, and just changing the context. And similarly with, I would say.
Okay.